My name is Ba. I'm the science and math tutor at the last time I did a video on zoology on how I prepare class, what I normally do during class and after class. So today I'm gonna do a video on what we did the last class. My last class was like the 26th last Tuesday. So I'm gonna review what we did that class. So we were doing genetics the other day. We completed genetics and started another topic, meiosis and mitosis. So I'm gonna go ahead and review some questions on the genetics and summarize like mitosis and meiosis too. So what I did my last class, I just went there, took my book, try and prepare like with my notes before going to class. So after going to class, I just tried remove my book and copy everything that she put on the PowerPoint and the notes. I tried and copy everything. And we had a lab after that too on like the various stages of mitosis, how to build the telophase, interphase, and all that stuff. So we did that in lab. After class, we tried to go back to my dorm and just review my notes so that I'll be able to understand like most part of it. So today what I'm going to do is solve some questions on the genetics and try and do some mitosis and meiosis too, and meiosis too. So the other class, like before the last one, the other class, he gave us like a worksheet. So that worksheet get like a lot of questions, but we did like a lot of them in class. So I'm gonna go ahead and do the last two questions, which is question 9 and question 10. So I'm gonna go ahead and do this last two questions. Okay, question 9. It says wolves are sometimes observed to have black coats and blue eyes. Assume that these traits are controlled by a single locus genes and are located on different chromosomes. Assume further that normal code column N, it said normal code is big N, is dominant. It said big N is the normal code and it is dominant. So it means wherever we get big N, whatever character the big N represent, that is the stuff that the animal is gonna have. For example here, big N means normal color. So wherever we see big N inside, it means the animal get like a normal color. And small n is gonna be the black color. So if a wolf get like black color, it means that one is represented by this gene, which is the small n, the recessive one. So the small n, for the animal to be able to produce that color, have to be like 2 of them. There should not be a present of any of the dominant character. The dominant character should not be present. If it is present, it will be normal. But if it is not present, if we get small n and small n, it will be black. So it's only black when we get 2 small n's. If we get double n, small n is normal. If we get double n's, it's gonna be normal. So these are the conditions. It's gonna be normal. If it is this one, it's gonna be black. And the next one, it say dominant to black and brown eyes. It said brown eyes. B is dominant over blue eyes. So it means blue eyes is going to be small b. So brown eyes is dominant over blue eyes. So for the animal to get black eyes, it have to get brown eyes, not black. You have to get only 1b to be able to get brown. If you get 1b, it's going to get at least 1b. You can get like 2b's, but it's still going to be brown. So for it to be blue eyes, for it to have blue eyes, it has to be like small b and small b, because b is recessive and big B is dominant. So if something is dominant, even if we get 1, the animal is going to get that one. That's going to be the phenotypic part, is going to be the character of the dominant one. Phenotypic is like the outward stuff it is going to show. It's going to be from the dominant one, not the recessive one. The recessive way to be able to show it is going to be it have to be like small b and small b for it to show blue eyes. That is the recessive character. So here what the question said is, suppose the alpha male and alpha female of a pack these are the dominant individuals who do most of the breeding, are black with blue eyes and normal colored with brown eyes, respectively. So if you say respectively, it mentioned the male one first, so it means the male one is going to take the first one. So the first one is said black with blue eyes. We say here black is recessive and blue is recessive. So if something is recessive, we can only get the recessive characters in there. So it means the male is going to be like this. If we get only one of the big ends, it means it's not going to have black, it's going to have normal because n is dominant over small n. So the next one, it said it get blue eyes. So if it get blue eyes, it means it have to be small b and small b, which is this part here. That is the alpha male. So the next one is, let me just put so I'll just go ahead and put male here. So the male is, it's gonna get small n because it's get black color and blue eyes, and blue is, it's not dominant. Black is not dominant too. They both like the recessive ones. So it's gonna be like this. So the female, it said the female get normal color with brown eyes. The color of the female is like normal with brown eyes. Normal is dominant, black, brown is dominant. So this one, just from that information, we will not be able to know the genotype of the female. But the question said further, the female is also heterozygous. So it means it's heterozygous means it get both of the traits, like both the normal one and the recessive one. That means heterozygous. If it is homozygous, then this one, homozygous normal, is going to be this one and this one. That is the homozygous normal. So the heterozygous normal is big N and small n. Heterozygous means get more than one of the traits. That is big one and small one. So this should be homozygous. This one is the heterozygous one. So it is normal color and brown eyes. So brown eyes too is heterozygous. So it means brown eyes is going to be big B with small b for it to be normal. For it to have brown eyes, it have to have this one. It can be this thing too, but the question said heterozygous. So it means we're going to get a homozygous. This one is homozygous. So it's going to be big B and small b. So here we're going to, the question said, it said what will be the genotypic ratio of this cross and what will be the phenotypic ratio of the cross. So we find the genotypic ratio and the phenotypic ratio, and the phenotypic ratio. So for us to do that, we have to cross these two. So when we are crossing, it's like you start with the gametes, that is the reproductive parts are the ones that are going to cross to form like offsprings. So if we look at the gametes here, the male is small n, and small b. The female is big N, big B, and small b. So we're going to look at what is the possible gametes that the male is going to have and the female is going to have. So the male can only get one possible gamete. It means it's only small n and small b. That is the only possible thing the male can have. It cannot have like any gamete that is other than this one. That's the only thing it can have. Because if we say this is going to be small n, small b, small n, small b, small n, small b, small n, small b. So it's still like the same small n, small b. So the female can get big N, big B. At the same time, it can get big N and small b. It can get small n, big B, small n, and small b. So the female can get all these possible gametes, but the male can get only one possible gamete, which is small n and small b. So we're going to cross this thing. This is what the male is going to provide, and this is what the female is going to provide. So we're going to cross these two and in a Punnett square. So here the Punnett square, let's put like the male on top. This is the possible gamete for the male, and the female is going to be, these are the possible for the female, So if we cross these two, we're gonna come up with this thing. It's gonna be big N, small n, big B, small b. Next one is gonna be this. It's gonna be this times this. That's gonna be big N, small b, small b. The next one is gonna be this times this. It's gonna be small n, big B, small b. The next one is gonna be small n, small b, small b. So here we're going to look at the genotypic ratio. So the genotypic ratio is like the inside stuff that we get here. So the phenotypic ratio is what this stuff is going to be like outside, what people are going to see. Is it black or normal or blue eyes or brown eyes? So here the genotypic ratio is going to be equals to what we get here. So we're going to put this thing in the form of ratio. So we get big and small n, big B and small b. So that's going to be 1. So we see how many of those do we get here? It's only one of them. So it's going to be 1. We get big and small n, small b, small b. We only get one of those here. It's going to be 1. So this one is going to be small n, big B, small b. We only get one of those. So it's going to be 1. This one we only get one of them. So it's going to be 1. So this is going to be the genotypic ratio. So the genotypic ratio sometimes is like, most of the time is different from the phenotypic one. So the phenotypic ratio is like the outward character, what it is going to show. So that one is going to be equals to, this thing get big N in it, and N is like normal color. Normal is dominant or black. So it means this thing is going to get a normal color and brown eyes. This offspring is going to get that normal color and brown eyes. So let's see like which ones are going to get normal color with brown eyes. This one is going to get black color with brown eyes. This one is black color, blue eyes. This one is normal color, blue eyes. So it means we're going to get only one of those. Only one of them is going to be normal color and brown eyes at the same time. So that is only one of them. So this one is going to get normal color with blue eyes. We're going to get only one of those two. So the next one is going to be, this one is going to get black color with blue eyes. So that one is only 1, 2. And the last one is going to get a black color with blue eyes. We get only one of those two. So this is going to be the phenotypic ratio. So here the phenotypic ratio and the genotypic ratio are like the same. This is black. This one is going to be black. Let me just use it in like this thing. Sorry, this thing is going to be normal with blue eyes. This one is going to be normal with brown eyes. This one is going to be black with blue eyes. Sorry, black with brown eyes. Brown eyes is capital B. This one is going to be black with blue eyes. This one blue eyes, brown eyes. This one is normal, black. So the phenotypic ratio is that. So that's the end of that question. So I'm going to go to the next one, which is question 10. So question 10 said, in humans, having a bent little finger is dominant to having a straight little finger. And having mid-digital hair is dominant to not having mid-digital hair. What possible genotypes and phenotypes could result if a heterozygous male and a woman heterozygous for mid-digital hair and a straight little finger have a child? So here it's saying like, it's talking about two heterozygous, a heterozygous male and a woman, a heterozygous male and a heterozygous woman. So here we're going to go ahead and start with this. I will use bent finger as big B, and the recessive one, like the finger that doesn't bend, as small b. And I will use like mid-digital hair as D. I'll just use D. Or I'll just use H. Let me just use H. You can use like any letter, it depends on you. You can use like any letter, but I'll just go ahead and use H. H is like bent finger. Sorry, mid-digital hair, and the other one, small H, is like the finger that doesn't get mid-digital hair. So this one is bent This one is straight. This one is hair without hair. So hair is dominant, band is dominant. So here I say, what is the possible genotype and phenotypes who result if a heterozygous male, and a woman heterozygous for mixed digital hair and straight little finger have a child. So here the man is heterozygous. So here the male is like heterozygous. So if the male is heterozygous, is going to be. So what possible genotypes and phenotypes will result if a heterozygous male and a woman heterozygous for mixed digital hair and a straight little finger have a child? So it means this one, they're heterozygous for mixed digital hair and a straight little finger. So if you get like bent little finger, that is dominant or straight. So it means straight is going to be small b and small b. And heterozygous for mixed digital hair is going to be big H and small h, because you say like heterozygous, like the last question. So it's going to be small h, big H, small h. That is heterozygous. This one is homozygous. Straight. Straight is recessive, so that's why it's have to be homozygous in the recessive form. So here we're crossing like the male and the female. Okay, we're gonna go ahead and do the gametes. So the male is heterozygous. So the male is gonna be big B, small b, and big H, small h, because the male is heterozygous. So here are the possible gametes we can get. The male can be either can get a gamete of big B and big H, and it can get big B, small h, small b, big H, small b, small h. So the female is heterozygous for mixed digital hair and a straight finger. And a straight finger is heterozygous for mixed digital hair. So that is going to be heterozygous is going to be H and small h for mixed digital finger. And straight, it gets like a straight finger. So a straight finger is going to be recessive, because straight is recessive. Straight is recessive and then is dominant. So straight is going to be small b and small b. So we're going to cross this male and this female. So the possible gamete for the male is going to be big H, small b, small h, and small b. That is the only two possible gametes we can get. Like it cannot get like another gamete other than that. You can either get big H, small b, or small h, small b. So that's the only possible ones we can get. So we're going to put the male on top and use the Punnett square across them. So the male is going to be big H, I'm going to start another one. Are you doing a video now? Yeah. Is it recording? Okay, the female is gonna be big H, small b, small h, and small b. So those are the possible ones for the female. So if we cross these two, this thing should be messed it up again. These things. Just put another one. So if we cross the first one, we're gonna get big B and small b. That's big B, small b, big H, big H. That's what we're gonna get on the first one. So the second one is gonna be big B, small b, big H, small h. The third one is gonna be small b, big H, big H. The fourth one is gonna be small b, big H, small h. So the next one is gonna be big B, small b, big H, small h, big B, small b, small h, small b, big H, small h, and small b, small h. That's gonna be the last one. So these are the possible offsprings we're gonna get when these two like are bridged together. These are the possible offspring we're gonna get. So here we're gonna find what is the possible genotypes and the phenotypes that could result. So the possible genotypes, we're gonna find the possible genotypes and the possible phenotypes. So here the first one we can get this is B is bent, is dominant over small b. So this is going to be BBHH. So let me do the genotype first and before so I'll do the phenotype after this one. So so the genotype is going to be BB big H big H. Let me see how many of those we get. Okay, it's only one of those. So the next one is going to be BB. We get two of those, and it's going to be 2B small b, big H small h. That is two of those. BB, it's big H. So BBHH is going to be only one. We're going to get only one BB and big H. That is only one. So it's only one of those two. So this one is BB, big H and small h. This one is BB, big H and small h. So we're going to get two of those. BB, big H and small h. We're going to get two of those. So the last one is BBHH. So BBHH is going to be 1 BB and HH. Let me see the ones we have. We get 1, 3 plus 4. We get 7 now. We get one more. So that one more should be, we get HH. Okay, we get another one that is big B, small b, HH. We get one of those two. So here the genotypic ratio is going to be 1:2:1:2:1. So it's going to be 1 plus 1 plus 1. That is 3, 4, 5, 6, 7. 4, yeah, 8. So it should be like 8 because we get like total of 8 boxes. So the genotypic ratio, if you add everything, is supposed to be 8. So let's look at the phenotypic one. So the phenotypic one is going to be, this one is bent finger and mid digital hair, because mid digital hair is dominant. So it's going to be bent finger and mid digital hair. This one is going to be bent finger and mid digital hair because H is dominant over this. This one too is going to be bent finger and mid digital hair. So it's like 1, 2, and 3 of them. So we're going to get 3 that are bent fingers, and mid digital hair. So it's going to be 3. Let me say, I'll just say bent finger and mid digital hair. So the next one is straight finger and mid digital hair. This one is going to be straight finger and mid digital hair. This one is going to be straight finger and mid digital hair. This one is going to be straight finger and mid digital hair. So we're going to get three of those, three straight, I would say small b, and mid digital hair, big H. And we're gonna get another one that will get bent finger and not like no mid digital hair. It's gonna get a bent finger and no mid digital hair. This one is gonna be a bent finger with, oh, we already did that one. So this one is gonna be bent finger with no, sorry, this one is gonna be bent finger with mid, without mid digital hair, bent finger without mid digital hair. So we're gonna get one of those. It's gonna get a bent finger without mid digital hair. So we get this one is going to get a bent finger at the same time it's going to get a mid digital hair. So we get one of those two. It's going to be a bent finger. Sorry, the finger is going to be straight, not bent. Small b is straight. So it's going to be straight finger and without mid digital hair. It's going to be b and small h. So we're going to get one of those two. So it's going to be 3 plus 3 is 6. 7, 8. So we should get eight of those two. So this is going to be 3 is to 3 is to 1 is to 1. It's going to be the phenotypic ratio. So those are it. Okay, I didn't show this one when I was explaining it. So I was just saying this is the phenotypic ratio is going to be 3 are going to have bent finger with mid digital hair. 3 are going to get straight finger. 3 are going to get straight finger with this thing. 3 are going to get straight fingers with mid digital hair. 1 is going to get bent finger. Sorry, yeah, that is bent finger. One is going to get bent finger without mid digital hair, and 1 is going to get straight finger without mid digital hair. This one is bent finger, mid digital hair, straight finger, mid digital hair, bent finger without mid digital hair, straight finger. That one is not part of it. Straight finger and without mid digital hair. So it's going to be 3 is to 1 is to 1. So that's going to be the phenotypic ratio. So this is the genotypic ratio. Okay, the next one I'm going to do is going to be mitosis. I'm going to do a quick overview of mitosis. So mitosis, this is the cell division that takes place in like the normal body cell, different from the gametes, like the reproductive cells. The normal body cells we get in our body, apart from the reproductive ones. Reproductive body cells undergo meiosis. So the other cells in the body undergo mitosis. So these cells, each of them contain 46 chromosomes, which is 23 pairs. So it means each pair like get 2, so it's like 23, and the total is like 46. So we're gonna do like the cell division that take place in those like normal body cells, which is gonna be mitosis. So mitosis, you get like different stages. You get prophase, metaphase, anaphase, telophase. Yeah, those are the 4 stages in mitosis. So we're gonna look at when the cell is in a normal form, like without undergoing any division. It is normally like this, not that like many cycles, it's just like one. So it's normally like this. This is going to be the nucleus. So the cell is like normally like this. Is called the interphase. That is the state when the cell is not dividing. The cell is just like normal, carrying like normal function. So this is the state we call the interphase. So the first state of mitosis is prophase. Prophase is like when the chromosomes inside the cell started like forming inside the nucleus, they start to become visible inside the nucleus. So I would say like prophase is just like we get like, I will use like 4 chromosomes. We get 2 big ones and 2 small ones. So these are the chromosomes. Each of them get like 2. This is 1 pair, this is 1 pair, this is 1 pair, this is 1 pair. So it's like a total of 8 chromosomes here. Like they always, I know they're more than that inside the cell, but I'm just using like total of 8 and stuff to explain how the cell division works. But they're more than that. It's like 23 pairs and 46 chromosomes. So this is the first stage. The first stage, they just become like visible inside the cell, and there will be this thing here called the central, I don't know how to pronounce it, central, and we will get one here, two at like the top and the bottom part of the cell. So this is the first phase that the chromosomes become visible. So the second phase is the metaphase. Metaphase is when these like chromosomes start aligning themselves in the center. Like they start, instead of like being like in this nucleus like this, they start coming to the center. Gonna be like this. So they start coming to the center. That is the metaphase, and they will get like bundle fibers here that will attach to the central. This is the central. So these are like fibers that attach to the central. So it's going to be kind of like this. This is the metaphase. This is the first stage, the second stage. This is the metaphase. This is the second stage. So I go to the third one. Number 3 is the third one is the anaphase. So anaphase is when the chromosomes start like breaking apart. The chromosomes start, like the pair of the chromosomes start breaking apart, and one will go up, one will go down. They start pulling like from each other. So that is the anaphase. So the anaphase is just like this. So the chromosomes are going to go like up, and this one will come down. I try to do it. So this is the anaphase state, when the chromosomes start pulling apart. That is the anaphase state. So the last one is the telophase. Telophase is like the cells are, this one have already divided the chromosomes and stuff. So now the cell is dividing itself, like the cytoplasm of the cell is dividing itself. So that's what is happening here. And this process is called cytokinesis. Cytokinesis, I don't know how to pronounce it. That is the process that the cytoplasm start doing like this dividing, that is called cytokinesis. So this is the telophase. So the chromosomes are going to be inside here and inside here, and the cell will go back to the interphase, that is the normal one, and it's like a cycle. So after interphase, it come back to prophase, metaphase, anaphase, telophase. So that's how it works. It's like kind of like a cycle. So this is the last stage, that is the telophase stage. So this is just like a quick summary of mitosis. So I'll write this one down. If you get a pair of chromosomes, like this chromosome and this chromosome are called, they're like sister chromosomes. This chromosome here and this one are called sister chromosomes. They're like on the same pair. They are called sister chromatids. So if you get another one, another pair here, another pair, so the chromosome here and the ones here are called homologous, chromosomes. These ones are homologous chromosomes. That is this one and this one. The pair of these two are called homologous chromosomes, and the pair of these two are called sister chromosomes. So these are the homologous, is when these two are called sister chromosomes. Okay, the next one is meiosis. Meiosis is like it's different from mitosis, because mitosis take place in like the normal body cells. That is the cells that contain 46 chromosomes. So this one, meiosis take place in cells that contain only 23 chromosomes. Like they don't have 46. They're not like in pairs of like 23 and get like 46. They get only 23 because they're like sex cells. They're called the gametes. So the gametes contain 23 chromosomes each. The gametes are like the sperm cells, and the X cells, they get like 23, 23 each. So those 23, 23 combined to form the 46, that is the normal body cells. To form a zygote, which get like 46 in it. So this one is only 23. So the division of this one is kind of different from like the mitosis. So if they're in like 23, this one is called the haploid number. This is called the haploid number. That is the 23 chromosomes. They're in like haploid number. The other ones is like 46. 46 is like, it's like they're in the form of diploid. So this one, the 23 of the normal body cells are in diploid, and the 23 of this one are in haploid. Haploid means they get only like one chromosome. They're not in pairs. So diploid is like 2 times the number of like one chromosome. So it's going to be like in a form of pair. This one is like the diploid ones. So this one's, I printed this paper from Blackboard, like she posted the test materials of Blackboard. After this, also like how to get to those test materials in Blackboard. So I printed this paper from them. So these are like the summary of the various stages of meiosis. So here it started here, 2n is equals to 4n is like the number of chromosomes. So it's like this kind of like 2 pairs, it's like 1 here and 1 here. So they get the interphase. The interphase is like the state when the cell is not dividing. When it's carried just like the normal body functions, like the normal functions, it is not dividing. That is the interphase. So here, these 2 are sister chromosomes. These 2 are called homologous chromosomes. That's the other one I was saying in the other video. So this one is metaphase 1, like it's the first one in the meiosis. So metaphase 1, there's like, this is the centroid here, this is the bundle fibers, and this cell will come to the center, like align themselves in the center so that they'll be ready like to be pulled apart. So that is the metaphase 1. So this is metaphase 2. See, like the cells are about to be pulled apart. The chromosomes, sorry, not the cells. The chromosomes are about to be pulled apart. So anaphase 1 here, they're like already like pull apart in this anaphase 1. They already pull apart. This one, the metaphase, they're about to be pulled out, and the anaphase, they already pull apart. The same thing here. The metaphase 2, they're about to be pulled apart, and the anaphase 1, they will be, sorry, the anaphase 2, they already like pull apart. So here, it's like the telophase. This is telophase 1, prophase 2. This is telophase 1 and prophase 2. So this one is kind of like different from mitosis. Mitosis is just only like 1 division that takes place, but this one is kind of like 2. You see, we get like, after the division, we get like 4 gametes with each getting like 2 chromosomes. Not like 2, like 8 will get like 23, but that is the stuff that is used here. So each is getting like 2. So this one is like, this one is different. In mitosis, we only get like 1 stages of it. That is metaphase 1, anaphase 1, telophase 1. Like we don't get 2 and stuff like here. But this one we get like 2 of it. Metaphase 1, metaphase 2, anaphase 1, anaphase 2, telophase 1, and telophase 2. Telophase 2. So here it's got like, it's like it undergoes 2 divisions instead of 1. So that's why we get like 4 gametes instead of 2 cells. We get like 4 gametes because it undergo like 2 divisions. So that's why it get like 2 phases. So this is just like a quick summary of meiosis. So I will show here on this thing how to access the test materials on Blackboard. So I will do it on this bigger screen, here. So if I go to my Blackboard, okay, this is my Blackboard right here. So I will just go to your name and just click the course like general zoology. So if you go to general zoology, you come to this part here. It said here, welcome, start working, my instructor, my grade. So you go to like start working. You go to start working. If you click on start working, you get like 2. You get class assignments and class materials. So you click on class materials. It's like test one material and test two material. So you go to test two material. So test two material is like this is meiosis drawings, this is reproduction and development nodes, and this is meiosis. So you just click on like, then you will get the nodes. So so this is how to access on like the test two material. So she said like the other class we go and make some read like these notes and stuff for the test. So this is the way like to go ahead and access those.